This is a static equilibrium problem. And it says, from what position should the rod be suspended so that it remains horizontal? So it's asking, where is O, that spot right here? Where is this? How do I figure out where that is in order for the bar to remain horizontal? So this is a torque problem, right? So we want, if it's going to remain horizontal, we need the sum of the torques to equal 0. So we need, so this is just like the sum of the forces, but it's the sum of the torques is equal to 0. And so what that means is that the torque term for M, if I think about it, M is going to pull down on the rod. And so it's going to be pulling down and going, causing the rod to go counterclockwise. If it could rotate about O, it would rotate the mass 1 would cause the rod to rotate counterclockwise, and M2 would cause the rod to rotate clockwise. So we're going to use the standard convention, and so we're going to say that the mass M1 is causing a positive torque. So we're going to say that torque for M1 is, remember, torque is equal to R cross F, and the R here is, we're going to use R1. So we're going to use this R term right here as our R1, and the force that M is applying is right at the end of the rod. So right here at the end of the rod. So our R cross F then is, they're all vectors. F is perpendicular to R, so I can just say the torque is RF. And we're going to say that it's really R1F here. So we're going to have M1. So the F is F1 in this case, we're talking about M1. So we're going to have R1, F1, and so that's equal to, the F1 is R1, M1G. So that's what I'm going to write in here, M1G times R1. Now if I want to figure out 2, so mass 2, my torque is going to be equal to R2 times F2, or crossed with F2. And so here my F is at the end of the bar, and so my F is going to be M2G. My distance R is from the pivot point O out to where the force is applied, and you can see that my R and my F are perpendicular to each other, so I'm just going to have R2 F2, which is R2 M2G. And I know in this case, this one is going opposite direction from my M1, so so I know I'm going to have a negative here. So if M1 is rotating counterclockwise, M2 is rotating clockwise, so they have a different sign. So that's where this comes in, M1 MG R1 and M2 G R2 is equal to 0. So what is R2? Well, R2, right, is just the total length of the bar minus R1. So we're going to say R2 is equal to L minus R1. We're going to plug that in. We have M1G R1 minus M2G L minus R1 equals 0. And now G is in both of our terms, so I'm going to be able to factor that out and cancel it. And I want to combine my R1s here. So I'm going to have M1 R1 minus M2 L plus M2 R1. 0. I want to combine my R1, so I'm going to factor that out. R1, M1 plus M2 minus M2L equals 0. I'm going to add M2L to both sides. So R1, M1 plus M2 is equal to M2L. And so R1 is equal to M2 over M1 plus M2L. So my pivot point is going to be R1, whatever we calculate this to be, given our masses and our length of our rod, that's where this position is going to be. I'm going to measure from one end of the rod to whatever length that is, and that's going to be where my pivot point is going to be, where I'm going to hold that rod so that it remains horizontal.